Good afternoon. My topic name is about boost converter simulation and efficiency evaluation, presented by Abhishek Tamale, Shubhangi Karaye, and Kalyani Roham, guided by Dr. G. Vijay Kumar. These simulation component are DC voltage sources. The function of DC voltage sources supplies the input DC voltage to the converter. Second is PWM generator. PWM is a pulse width modulation. This generate PWM pulses to control the switching timing. Constant block means duty cycle. This function is set desired duty cycle for PWM. MOSFET. This function to turn on off based on PWM to transfer the energy. Third component is diode. Diode to provide the current path when MOSFET is off and blocks reverse current. Second one, inductor. Inductor to store the energy during the MOSFET on and release it during the off state. Capacitor is denoted by C. Filters and stabilize the output voltage. Resistor, diode, its function represent the output and load receive the power. Voltage measurement to measure the voltage at input and output points. Current measurement measure the current in the circuit path. Product blocks calculate the power and multiplying voltage and current. Display the function of display show the real time numerical values and scope to show the waveform plots. This is a simulation of our topic. So I'm Kalyani. I'm taking the components which is useful for the simulation. So first is DC source. This is the DC voltage source. Now I'm taking the pulse width modulation generator. This is MOSFET. This is the series RLC branch. Now I'm taking the first stage R load. Again for the inductor. And the last one is for capacitor. Now I'm taking the voltage measurement and then current measurement. And this is the product. This is the display. And the last is scope. So these are all the components we are using for the simulation. I'm setting the parameters for this component. So amplitude is 18. Now the for the load resistance is 12. 12 ohm, and for the inductance 45 ratio minus 6. For the capacitor is 55. 5.5. For the diode resistance 6 0.011. So as it is. For the forward voltage 0.8. For this number it's the same. And for the MOSFET it's resistance rho it is 0.1 ohm. Then the resistance RD is 0.01. This is the number resistance is 1 raised to 5. So now the same. Now I'm taking the parameters for pulse modulation. The frequency is 40,000 and the sample time is same as 0. So this all the parameter we are fixing for this all component.
Now we are doing the connection of the simulation. First we connecting the current measurement in the series with switches and voltage source. After this connection is done, we'll meter in parallel with the DC voltage source. MOSFET is connected to the diode and inductor is parallel with MOSFET and diode. After that, we are for the load side, we are again connecting the current measurement in the series with the load. Connect display to the voltmeter. Then connect the PWM generator to the MOSFET. Connect the current measurement and voltage measurement for taking the product of that to the product block. Connect it to the scope for checking the waveforms. After that, connect the current measurement to the load. We are using the resistor load here. And this then connect this negative terminal of the voltage measurement to is parallel. After that, connect this terminal to here downside. Connect the voltage measurement in parallel to check the output voltage. Connect it properly. Connect the voltage measurement in parallel with this. Okay, this is connected. Adjust it properly. Connect this display to the voltage measurement. After that, to connect the product to that scope, seeing the product of the current and voltage, and one terminal to the voltage measurement block. Then for seeing the waveforms of the both current and the voltage, we are use the two layout scope connected to the both. For again connected properly to the adjust the circuit properly. Here the connections are done. Then we can see the result. For our topic of the presentation is the buck boost converter. For buck, we are giving the duty cycle for point 4. Of the below the point 5, the buck it acts as the buck converter. We can run now simulation. Here we can get the 12 point approx to the 12.52 71 voltage. It means we get the step down of the voltage, and we are giving the 18 voltage DC voltage 18 volt. Here we get the 12 volts. It means there is the step down of the voltage. Now we are giving the duty cycle above point 0.5. We are giving the point 0.6. Now it will act as a buck converter. Now you can see here there is the step up of the voltage. It will be like the 26 point something. This is all about our simulation and efficiency evaluation of the buck boost converter. Uh, and we can step down and step up the voltage by the buck boost converter, and we can get the 26.19 as the step up voltage. Thank you.